My name is Jensen Jiaxin Lim, and this is the video for Lab 1 for Physics 2211. The purpose for this experiment is to observe and analyze a moving object in a straight line at a constant speed, and using this to investigate the fundamentals of physics. We will use this in a tracker software to extract position time data so we can build a computational model based on the momentum principle, which is also known as Newton's second law. According to Newton's second law, the acceleration of an object is directly proportional to the net force acting on the object. But when we're coming to this experiment, we're going to expect the velocity to not change at all, as it's going to remain constant. This means that there's not going to be any acceleration and there's not going to be any change in the velocity. Therefore, net force will equal to 0. And how this correlates to the velocity equation? According to the equation, see that the final velocity is the addition of the initial velocity with the net force times time divided by the mass. But since the net force is 0, therefore you will get your final velocity to equal to the initial velocity. So for this experiment, we're going to be using a basketball, a flat surface, a camera, and the tracker software. How this is going to work is we're going to have the basketball roll across a flat surface for a distance of 0.95 meters. The time will be taken throughout this whole experiment to calculate the velocity. The expected velocity should be constant. After inputting the data into the software, on the left-hand side, you get the experimental data based on the tracker software that I was using, and on the right side, you'll see the computational data graph based on the data that is put into the code. To further understand how the tracker software works is by using the axis. You can see that the axis is slanted at an angle, and the reason for that is because the ball has to be parallel to the axis. Another thing to note is that the force applied has to be constant so that the ball does not accelerate, because we want it to travel at a constant velocity. How do I know this? It's through the graph at the top right-hand corner, through the displacement time graph. You can see that it's pretty linear, which suggests that the ball is traveling at a constant velocity. After grabbing all the data, you can input all the data into the code. For example, you can input the ball position, the ball velocity, and the time taken. In this case, the time starts at 0.7 seconds because the ball does not come into the frame 0.7 seconds after the video has started recording. And the ball stops moving after 1.933 seconds. Once you input all the data, you should be able to get the graph from the next slide. As you can see, the position time graph is completely linear, starts at 0, and the velocity time graph is a complete straight line, suggesting there is no external forces acting on the ball. After producing the graphs from the code and tracker, you can see the difference between the two graphs. There's not much difference between the two. Both are pretty linear. However, you can see the observational data is slightly curved compared to the computational. While the ball is traveling almost at constant velocity, it is important to take note of the possible errors that could affect the velocity of the basketball. Some of them include the friction, uneven surfaces, and air resistance. So here are a few interesting things to think about. So what if you flipped your axis on the tracker? How would it change your graph, or would it remain the same? For this case, when you flip the axis, that means your graph will be flipped to the opposite direction. Because since in the video, the ball is traveling to the right-hand side. But if you flip the axis, that means you're saying the ball is traveling to the left-hand side. However, the shape of the graph will still remain linear. The reason for this is because the ball is still traveling at a constant velocity, so the overall shape remains the same. Is it possible for you to say how many push and pulls are added together to give 0 net force in the case of that you observed? So what does this mean? Well, the total net force in this experiment is 0. That means all forces are balanced in this experiment, so it's very difficult to say what kind of forces are still acting on the ball. It could be the force of gravity. However, the force of gravity only acts in the y direction, which does not affect the ball in this case since we are only taking account of the x direction. So therefore, the ball could either be at rest or it could travel at a constant velocity according to Newton's first law of motion.